Chapter 3 or Module 3, look at example 1, solving a polynomial equation by graphing. So here we have this equation right here. There's no y equals or there's no f of x. So what we want to do is we want to find the related function first. So that's just setting the equation equal to 0 and then changing y to f of x, or changing 0 to f of x. So if we just add the 4x cubed to both sides, and there's no x cubed, right? That's an x to the fourth, x squared, so it's going to go in between here, right? And so my function is x to the fourth plus 4x cubed. One thing you can think about is what is the degree of this polynomial? And that will kind of let you know how many times it might cross the x-axis, right? And so we can do this from a graph. So now let's set equal to y, we can change that, or set equal to 0, we can change that to f of x or to y equals, right? And then we can go in our calculator and we can type in 4x to the fourth, 4x cubed plus 3x squared minus 5. We can graph it. We might have to adjust the window to kind of see what the window looks like first. So a graph, it might look like this. So it looks like they're counting by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So their window is, oh, it's right here. Their window is right here. So if you want to adjust your window from negative 10 to 10 on your x's and scale by 1, and then negative 10 to 10 on your y's and scale by 1, and then hit graph, and you should see this same graph on your graphing calculator. And then our goal is, again, is to solve it, right? So we're looking for these x-intercepts, and we can see from the graph it only crosses it twice, right? It says to the fourth, so it might cross it 4 times, but here it only crosses twice. You can see that from the graph. So we want to find out what these zeros are, right? A couple ways to do it. Think about what's one way to do it. And one way to do it is to find and locate those zeros, right? So we press, first we press, let's see, first we press second trace, right? So this calculate over here is by pressing second trace. And what that does is goes to the calculate button. And when you're on the calculate button, you want to go to the zeros where it says 0. And then once you're on that zeros, you can, it will say left bound and it will say right bound. Okay, so the left bound for this point, if I want this one, the left bound is going to have to be above, so it's going to have to be a positive. And then the right bound is going to have to be a negative. Right bound is going to have to be a negative. And then you can go ahead and guess. And guess, you can either click one of these. If you want to guess one of those, that's fine, or whichever one's closer to the intercept, and then hit enter. And then it's going to give you this x equals this, where it's really close to 0, right? Okay, so that's our x-intercept, or our 0, or our solution. And then I can go to the other side and hit second trace again and click on zeros. And then I can do left bound. Left bound here is actually going to be the negative. And then right bound will be the positive, a positive number. And then we can guess and then hit enter, and it's going to give us 0.84-ish. Okay, and so those are our zeros. Now, what's another way that you could do this? Well, another way is to use the table, right? So I can hit the table button, which is second graph, and I can look for where it goes from positive to negative and from negative to positive, so that I know it's between, my x is -4 and -3, between -4 and -3. And then this one's between 0 and 1. And we've done this before with quadratics, right? But how could we maybe be a little bit more accurate, right? So these are integers. Can we even be more accurate? And so think about that question. How can you use your calculator or the table feature in order to be more accurate? Okay, how could you zoom in on a table? So think about that. Be ready to answer that when you come to class.